Hello, everyone. All right, so what we're going to do here for starters is anything I mention is following one of four things. We're either following NIST, we're following NERC, or we're sticking to IEC, or for the people, all three of you from Australia in the room, we also set it up so it follows the ACSC as well. There are two principles of efficiency that you can use for this, either in this conversation or when you're cooking. One of which is to try and eliminate the part or process. The second is to never touch something twice. Clearly, you're not going to fully follow that, but keep those principles in mind. An OT DMZ asset for the purpose of this conversation is anything that needs access both to the OT environment and to the outside world, whether that's a higher level within the Purdue model or something off-site, in order to function properly. And when you have an OT DMZ asset, chances are you have several of them, and chances are you have several facilities, in which case you find yourself having duplicate licenses. Now, how much of a problem is that? So we went around and we asked factories and project owners all over the place, and the end result was this is a very large problem. I don't care how big you are as a company, $70 million still means something. And these numbers in the abstract, well, they aren't that impactful, but what I've noted anecdotally is duplicate licenses tend to represent 7/8 of the total cost of the OT DMZ assets that are held by a particular institution, which translates for the ones that were publicly listing their operating costs to about 2 to 3% of their overall operating expenses. So this isn't a tactical problem. This is a strategic level problem. The other issue is that some of these OT DMZ assets are going to require human intervention, which means they're touching the exact same piece of paper in different factories twice. Now, in terms of how much money that equates to, the answer was it's exceptionally variable. So depending upon what industry you're in, you're going to need to map your own processes to find out. Now, the solution path for this, if you're an engineer, is pretty straightforward. This is a tractable problem. Namely, from a technical point of view, the world has fixed this over the past 5 years. Once you've solved the technical problem, then you approach this as a process problem. And then once you've resolved that, you then go out and you seek group consensus. What I would like to note, though, is if you try and follow that process, what you're going to find is a lot of resistance. There's a far better way to do this. Clearly, you think about it before you go out and do this. But what I would argue is you should solve this by first achieving group consensus, then building out your process, and then going through a technical approach to it. Now, since we're all engineers, we're going to do it in reverse to this, now that I've told you that you're not supposed to do it this way. So from a technical point of view, first, this is your OT DMZ. Nothing fancy here. The OT DMZ piece is up at the top of the Purdue model. It's 3.5. If you have 130 factories, they're all going to be laid out roughly in the same fashion. From a categorization point of view, yes, the networks are going to be different. And if you want to move your OT DMZ assets out of the individual facilities, step one, park them all up in an SD-WAN. That's it. The hard parts are the things that are related to that. So what you've created by moving all of these assets into a central location is a candy store problem. Namely, if I want to find the candy store, I follow any one of the children in the town. If I want to find a particular kid in the town, I follow one of the other children up to the candy store, and then I see the kid and I follow them back. It's kind of creepy. But the way you solve this problem is you have to disintermediate the candy store from the kids. And you need to do this in a way that doesn't create a readily identifiable path, which means you haven't actually solved the problem. If you are following NIST, the answer for the past 3 years in finalized form has been you need to make this a moving target defense SD-WAN. If you're not following NIST because you're not in the United States or you're able to get away with it, right now, anything goes. No one's going to hold it against you. When you look at the perimeter, though, there are some basic hygiene rules which everyone needs to follow. First and foremost, the connections being established out of these different facilities up to the SD-WAN need to initiate in an egress-only fashion. You should not be using a regular VPN, which is listening all the time. So you reach outbound only, you establish the connection, then you have two-way traffic. Second, clearly decrypt before it enters the proper security stack. So on the edge, that's where the encryption gets pulled off. Then it can go through your layer 7 firewalls. And third, it should only be on when it's actually needed. I found that a lot of people look at industrial processes and presume that they are continuous. They are not necessarily continuous. So if they aren't continuous, let's say the plant goes down for the season because it's a timber plant, well, you probably shouldn't have the thing sitting there on all the time. When we look up at the data transport layer, there are two key things to remember. The first is, if you have a $70 million problem, you can afford the extra $50,000 chunk of change to pay for the hardware security modules so that you can properly follow RFC 8603, the CNSA suite. The other thing is, that data transport layer should also only be on when it is needed. Now, there are two questions, if you want to do this, you're going to face from other engineers, namely industrial engineers. The first is going to be, will this negatively impact reliability? And the second is going to be, what exactly are you going to move up there? So on the reliability front, the way to approach this problem with people is to remind them that if you are dealing with an OT DMZ asset, it only functions if three things are stable. First, whatever it is that that asset needs to reach outside of the OT environment in order to do its job properly. Second, the backhaul running from the facility out to that asset. And then third, the OT DMZ asset itself. Now, if we unpack that, you get this formula, which is the probability of a particular plant running is equal to 1 minus the probability of that off-prem system failing times 1 minus the probability of the backhaul failing times 1 minus the probability of that OT DMZ asset itself failing. This is, I promise you, the only time I'm ever going to show you an equation. But if you draw this for people, and they're industrial engineers, the first thing they're going to say to you is, yeah, that's my model. The way you get around this is you say, well, the off-prem system is going to fail whether or not you like it or not at some point. That is not impacted by the fact that I have 5 or 1 OT DMZ assets. Second, the backhaul has nothing to do with this. If the backhaul goes down, it doesn't matter whether the OT DMZ asset itself has gone down. So we've isolated this to one line item right at the bottom. And the mistake that the industrial engineers are making is they seem to think that all of these assets operate independently from one another. That's just not true. The piece of software, if it fails in one place, in a time-framed manner, will fail at the same moment someplace else. Or it's an underlying thing, which has nothing to do with the OT DMZ asset. So, now that you've covered that up with your mathematicians, then the question is, what are you going to move up there? There are two ways to think about this. The first are the obvious things, and that's where I would recommend you start. Those are license duplicates, your authentication mechanisms, your monitoring team, and remote access. The second is the structural stuff, which ends up being worth more money, and that's process related. When you're looking at the obvious stuff, the reason why it's obvious is it's a line item. And the value per facility, depending upon who we talk to, range between $200,000 and $300,000 per year per facility. That's enough to get people out. The second, though, is the structural one. And here, again, it's quite variable because humans are involved. What I was able to pry out of folks was it ranges from about $180K to $700,000K. Now, I should stress this is extremely anecdotal, so you should find it out for yourself by mapping your own processes. Now we turn to the second thing, which is how do you get this done? There is a predictable pattern you can follow if you want it to actually work. There's also the triage approach, which does not work, it seems, ever if you have more than 15 facilities. First thing you should do is you should do an asset inventory. Second thing you should do is a governance model. Third thing you should do, and you should not skip this, is perform a risk assessment based off of that asset inventory and governance model that you've built. If and only if you have done those three things, are you ready to implement an OT DMZ bridge and then over time onboard the capabilities in there? When you're doing the asset inventory and governance models, for folks who haven't been out at the plant floor that much, step one, the easiest way to develop a good asset inventory is to go find the things that people care about in physical form. You're going to find that because those are the things that the people at the plant take care of. So that's the easiest way to get an early look at what are the things that might be in my asset inventory. Don't send people who don't smell like the campfire. Do not send the junior-most person. And make sure that the people who are sent are succinct, because you're an intrusion into their lives. And finally, I don't have a dog in this fight, but what I have noticed is if you're only spending $50,000 to get this done per facility, you're going to find yourself spending $50,000 again and again and again. This is a $200,000 problem to fix from a services point of view per plant. In terms of onboarding, diurnal cycles really matter here. So find out what morning looks like at each one of these plants, time zone-wise. Work inside of their mornings. Onboard one plant per morning, onboard one capability per morning. Some lessons learned the hard way. For context, the company I work for builds moving target defense SD-WANs. Therefore, we found it to be very lucrative to get in front of companies that had made it to the point where they were implementing unified OT DMZs. So you start trying to learn the process. And then you start trying to learn, well, how do I get into that process? A couple things. This is the process that I tended to see. It was not the process that my colleagues tended to see. And the reason was I was only looking at very large companies. If I was in the room, it had over 100 facilities. The other people in the firm were looking at companies that had fewer than 15 facilities. And as I said before, what was happening there was folks were just triaging things. They'd see a problem, they'd fix the problem. But if you're looking at a bigger company, because you work at one, there were a few patterns that I noted. First of all, why in the world is everyone doing a risk assessment? Why do they have to do that if they see the problem and they could fix it? Second, why is it that every company that's done a risk assessment does not necessarily process into seeking an OT DMZ? And third, who the heck started this process in the first place? And what I came to realize is the reason why you were seeing these processes was because people were seeking group consensus. And a lot of these were symptomatic manifestations of people being unable to agree on something. So risk assessments were triggering group consensus. And show of hands, I can't actually see any of you, but how many of you work at firms who on any given week can't agree on the color of an orange? Actually, I can see you. It's a lot of them. So what ends up happening is you get into a room and you say, we have a problem. You explain it to everyone else, and they say, we all have a solution. And you end up with a vanishingly small point, which turns into a product, if you are a company that's gradually trying to grow into something big, and that's what you keep trying to sell. And it's pretty easy to do that if you can stay inside of that center point on the Venn diagram. If you have a structural problem that you need to change, you're going to have to use a different approach. Namely, you're going to have to go out to people and say, you haven't heard of this problem before. Let me explain what's going on in the world here, and we got to do something about it. And what you'll notice is, even if they're in accounting or they're in the legal section, if you have the patience to explain to them the problem as you see it, odds are they're going to be receptive to the solution that you describe to them. So asset inventories, governance models, and risk assessments have largely become productized. You can throw the dart and you can hit the center of the Venn diagram, which means that, and to prove anecdotally that this is what's happened, you can get lots and lots of salespeople to sell it, because it's not that hard to do. Most of you were probably at the cabanas earlier. You're probably going to be hanging out with people again later today. Look for them to say a sequence of phrases. I'll show them in a moment. When you get down to the OT DMZ problem, though, that's a far larger problem. So most people aren't trained to deal with it. So I'll skip that. If you want to achieve group consensus, this is the pattern I've heard that works. The first is you walk into the room and you explain things the way you see them. So the standards changed starting in 2019, and the tech has caught up to allow us to do something we couldn't do before. And I think this is going to represent a 2 to 3% reduction in our operating expenses overall. And that also fixes a bunch of security initiatives I wanted to achieve. Now, if you're telling this to someone who works in a completely different department, cybersecurity has been Dr. No for many years, and now you're telling them that you want to do something that'll actually reduce costs, that's going to blow their mind. They will be sitting there asking you, okay, go on. So the process we're going to do this right, and we're going to do this once. And that means I'm going to need a team. And they need to be aggressively competent at their jobs, which means I either need to pull them in-house or I need to go and find them from outside. In either case, I need you to back me on this. And third, from a technical point of view, let me show you what this actually looks like so you can understand what I'm going to be doing. Now, I know everyone in this room knows this. What I'm going to do is I'm going to show you how to explain this so it works. I've seen this done a couple of times. I've also done it myself. It works even if you're talking to people who work in wastewater who have never seen a network diagram before. So brace your eyes. We're inverting colors because I'm not an artist. You're going to start by teaching them the Purdue model. And the way I do it is I say, right, what you're looking at here is level 0. This is the process layer. This is where you're looking at motors and or sensor systems. Those things feed up into the station level. Now, the station level is where you're going to find components that do not get modified once they leave the plant where they were assembled, aside from having a button or two on them. What I've put onto this diagram are examples. They're not necessarily the things you're going to find in those levels. We're going to work with you together to, one of the things I want to do by building this asset inventory is, in fact, get this properly all categorized out for our firm. Then you go up to level 2. That's our work set level. That's where you're going to find the things which show up as software but have a lot of configurability. My SCADA system, for example. Then I'm going to go up to level 3. This is where I'm going to find the things which are highly configurable and or written in-house. And above that, we have the OT DMZ, which I was talking about, and everything here is the OT environment. The number of people who I have met who run factories who never knew what the heck anyone was talking about in their firm when they mentioned IT or OT is astounding. Someone needs to explain this to them. Most of the time, once you've done that, they're willing to follow along. In any case, you take them further and further up the Purdue model. You explain what the IT network looks like. You explain that to get between these different levels, you need a disposable intermediate component according to the standards. And then you say, right, so that's one plant. We have all of our other plants. What I want to do is I want to follow the following pattern. I need to have a device up on the OT DMZ. It's going to decrypt everything before the firewall because that way my firewalls can read it. And it's going to reach outbound only so that way I don't have the problems of old. Remember when our VPN got hacked? It's going to tie up to an SD-WAN. You probably should explain to them what that is. And then we're going to have the exact same layout at every other factory. What I want to do for access is I want to give people those disposable intermediate components. And access is going to be fast because, yes, I have to launch those things and spin them up. I'll have an inventory of them, and it'll be automated. And the same experience is going to be happening for people who are at the plant because access should be the same experience whether you're at home or you're at work. And then I'm not going to do this instantaneously, but I'm steadily going to take things from inside the DMZ and shift them over into this network. And finally, that whole thing I was talking about having, which was continuous monitoring, and you rejected that in the last budget proposal, I'm going to do that too. But I'm only going to need to do that once. When you do it this way, people like you, because you haven't confused them. You've shown them how to go through the process. And by the way, if you want these diagrams, just call me up or email me. That took less than 4 minutes to do. Clearly, you should go a little bit slower in real life. In fact, it took 3 minutes and 30 seconds. But it's going to get the job done. So let's recap all of this. What we covered is a problem that has strategic implications. You're looking at something that's worth 2 to 3% of your operating costs. That moves the needle. The technical part is not hard to solve anymore. It's been solved for years. The idea of creating a bridging network is not that new. And solving it in a manner that is consistent with the cybersecurity standards has been something which does not require any wizardry either. The hard part for all the engineers in this room is group consensus. It's what we're screwing up. So if you want to do group consensus, the way to do that is you go and explain it to everybody, and then they're going to follow along because you've defined the problem in your own terms. Once you get underway, undertaking an asset inventory, establishing a governance model, doing a risk assessment, those things get a lot of stuff done that you wanted done anyhow. So you just apply process towards an end goal, which makes everyone happy. Now, on that note, thank you very much. Have a good one.